Greetings, I am Maleficious, and I'm back with more of Shenzhen IO. Well, last time I got through the infrared sensor puzzle, and I managed to come up with a solution to the buzzer puzzle somehow. And in the space between, I managed to come up with a solution for the wireless controller puzzle. But first, I want to go over some stuff in the manual document, rather. So, if I could just... yeah. So anyway, first the application notes AN650 here, which is using reference design touch activated light controller. Yeah. Following circuits, this is what I was using for... well, at least I was referring to this at first for the buzzer, I think. But yeah, this is supposed to... yeah, input comes in here, goes out here. This doesn't exactly do a loop, does it? Yeah, no. Not really. But anyway, then there's also this application note, which is pretty useful. Yeah, application note 268, two interfaces, limitless possibilities. There are two types of pins on the MC XXXX microcontrollers, Simple I/O and XBus. Well, it could be MC4X. I'm not sure how this is supposed to be pronounced. Note that they are not interoperable and can only be connected to another pin of the same type. And Simple I/O, yeah, continuous signal levels 0 to 100 inclusive. But the important part is XBus. XBus values are discrete data packets from -999 to 999 inclusive. XBus pins are marked with yellow dot. XBus is commonly used to transmit data between two microcontrollers or a microcontroller and a complex input-output, such as a keypad or a numeric display. In Simple I/O versus XBus behavior, Simple I/O pins can be read or written at any time with no regard to the state of connected devices. But this is what keeps tripping me up, I think. XBus, however, is a synchronized protocol. Data over XBus pins is only transferred when there is both a reader attempting to read and a writer attempting to write. If a read or write attempt is attempted without a corresponding operation on a connected device, the operation will block. And that's pretty important because I keep thinking, I think it's how I keep getting tripped up in using the XBus ports. Oh yes, one more note. The control panel. This is your options menu. So, yeah, resolution, full screen sound volume, music volume, auto format code, puzzle archive, re-verify designs. Anyway, back to concept mail, and I might as well show you my solution for the wireless game controller. This took me maybe half an hour in game. But anyway, yeah, once again I'm using two MC4000s to handle the two simple inputs, and an MC6000 to handle the signaling. And once again, we've got this RF chip here. RX comes in, yeah, radio RX is non-blocking XBus input connected to radio receiver, so data comes in from here. And radio TX is an XBus output connected to the radio transmitter. So, when a data packet is received over the radio on the game console, we have to respond with a 3-value data packet, making sure to use the most recent input values. So, basically, we don't really have to track all of the values until a packet comes in. So, what's going on with this main controller? We're testing if x2 is less than -1. Basically, if it's -9, because we don't get anything other than -1. Well, or rather, the only inputs we seem to get are -999, which means no data, and -1, which means data request. So, if it's less than -1, we just jump to the end, and the end is sleep 1. But if we do get a -1, the first thing we do is move -1 to x0. So it goes through here, and then we set it into a sleep until it receives from x0. And here we handle the x and y, which we've got it set up to sleep until it receives input from x0. Then, yeah, and then this is where it is. I have to execute a read command, otherwise it blocks. So we have to test if it's less than... I set it up to test less than 0. If it's not, jump to end, because I suppose that's gonna, I don't know, maybe error handling or not. But anyway, first we move value from P0, the X value, to X0. And so it goes back up, we get data in, we move the X value in X0 to the accumulator, and then, because we have to write it first, otherwise it blocks. And we then move the accumulator to X3, which starts creating a data packet. Then we set this to sleep again until it receives new data from X0. And so it comes back to here, and we move P1, the Y value, to X0. And then we set this to sleep for 1 unit. And once again, I move the X0 value into the accumulator because I have to read or write in order to clear the X bus. And then we move the accumulator to X3, which should put the Y value into a new packet. And then we move a value of -1 out X1, which goes into the handling of the A and B inputs. So again, I've set this to sleep until a value comes out, until a value comes in. And again, I have to test if it's less than 0 to read it. And of course, if it is, so when it is, I move it 0 into the accumulator, and that's important because it resets the microcontroller. Because here's what it needs to do. So again, the state is we have to transmit a value of 0 if the input from A and B are both 0, a value of 1 if A is 100 on and B is 0 off, a value of 2 if A is off and B is on, and a value of 3 if both A and B are on. So first, we test, after the reset, we test if P0A is greater than 0. If it is, we add 1 to the accumulator. And then we test if P1B is greater than 0. And if it is, we add 2 to the accumulator. And then move the accumulator to X0 and then set this to sleep 1. So again, this was set to sleep until it receives input from X1, and once it does, we move X1 to X3, then we hit the end at sleep 1. So this should work, because it looked like it worked solid. Yeah, because if we just step through, test, and now, well, or rather, we step through, test if it's less than -1. It's not right now, so it jumps to the end. Then the next step, testing if it's less than -1, and we're getting a -1, so a request is coming in. So first thing we do is move -1 to the X0. And so now we're down to here, we're testing if it's less than 0. And it is. So that clears out the X bus. So now we can move P0 out. It's going out to here. Then we move into the accumulator so that we can clear the X bus port. Then move the accumulator to X3. And all this is taking less than 1 time unit. So we move it into moving the accumulator into X3, and at the same time we're moving P1 into X0 on this microcontroller. So we moved it out, and this packet here started with this value of 63, which was the X value. So we're moving this X0, the new X0 value from this X0 into the accumulator, and that clears the X bus. And so we've hit the end with this, and we're setting it to sleep for a tick, and we move the accumulator into X3. So yeah, now this is in a write state. Right, so if it's getting data in, it's in a read state, and if it's moving data out, it's in a write state. Then we're going to move -1 along X1, so that puts this one into a write state. And then we test less than, so we can get this cleared. It is, so we clear the accumulator. Test if P0 is greater than 0, it's not. And test if P1 is greater than 0, it's not. Move the accumulator out, which puts this one into a write state. And then we get data from here, move it to X3, and then set this to sleep. And then this one sleeps for 1. And it seems to work pretty well. So we advance a few more times. And then we're here. So here's how one works with A and B in some combination of on and off state. Moving it through, we get the X value and the Y value, and then we go in, test list. So yeah, goes through, we move 0 into the accumulator reset, test if P0 is greater than 0, it is, so we add 1 to the accumulator. Test if P1 is greater than 0, it is, so we add 2 to the accumulator. And then move the accumulator to X0, and push it out a value of 3, and then we just move that value of 3 out. And so if we advance a bit more... Okay, so we got a point here where it looks like A is off but B is on, as we can see here. So if we step through... Okay, so move -1 in here, and you can see the accumulator is still at 3, which is why I need this reset here. Otherwise, it would just keep adding on, and we'd get wrong data values out. So yeah, test P0 is greater than 0, it's not. Test if P1 is greater than 0, it is, so we add 2, and move that value of 2 out, and it gets the correct data packet. So I'm just going to run through the simulation. And I'm going to have some more water. Yep, it's a good thing we only had to design the controller and not the game box unit or whatever. Or at least we only had to design the wireless. Ooh, okay. Wow, a lot of people managed to do it a lot cheaper than me. And a lot of people use less power than me, and I used the most code. Okay. Well, clearly my solution's inelegant. Thanks, mate, I owe you one. You've just helped make thousands of dead-tired salarymen marginally happier. That is, if they actually find the console and use it to play a game before passing out. Ah, yes, pod hotels. Not sure if they actually exist. They probably do, but... I don't know. Okay, next one. Feel the connection and get ahead. From your virtual friend, info@buddybots.friend. Well, this can't be good. Are you lonely? Do you feel isolated and disconnected from the world? Scientists have shown that a lack of real-life ties to others can lead to depression, which in turn can negatively affect performance at work. Don't let the lack of human interaction reduce your effectiveness. Virtual friends from BuddyBots are quality friends nearly indistinguishable from real-life people. Wow. Our characters are developed by the world's top personality designers and are completely customizable, so whether you want a supportive presence to help you through a difficult time or a flirtatious sidekick to banter with throughout the day, you're covered. Subscriptions are flexible and competitively priced with other bot companion services. Stop being lonely, feel the connection, and become a top contributor to your company's success. Now clearly this is a natural progression of chat services like IMVU, I guess. Oh well, next project. Tag you're it. Laser tag equipment. Oh, I wonder. Not sure if this is... I don't know if this... I think this may have been inserted. This puzzle may have been inserted. Anyway, from Carl Teskey. Please don't blame me for this. I have a friend, more like an acquaintance really, from a while back, many jobs ago. He's always been a bit of a nutter, and I guess what happened was he made a decent bit of cash with an app or something and decided to retire from the programmer's life and build laser tag arenas for the rest of his days. That's not the worst of it. He's calling his franchise to be the Awesomeplex, capital is his. In any case, we wanted to see if we could make some scorekeeping wearables for it, and I said yes. I'm not entirely sure why. I suppose in the unlikely event his arenas do take off, it'll look brilliant in hindsight. From Joe. Awesomeplex! When it's done, we should try a match in the office. Laser tag looks like so much fun. Oh, a lot of simple inputs either on or off. Too many for a microcontroller on its own, but a good use for the DX300. Ah, looks like we're getting a new chip to play with. Okay. Whoa. Can I zoom in or out? No.